about AI as we do. This is not the most technical talk. I think there's a technical period in it because when you don't know who exactly your audience is, that's definitely the safe direction to go. Many of you in this room will learn that the hard way when you just lose people by being too technical and really research-centric. But it's fun to kind of learn this. And this is my broad intro. Everyone is hearing about reinforcement learning these days, and I've already double-clicked. I wanted to start on kind of what would be called a boomer reference paper. I think T.D. Gammon, it's either 1992 or 95, I think it might have been pre-printed in 92, was a paper, it's Tesoro et al., and really not a ton has changed in DeepRL since then. I think this is a paper from 1992 where they use self-play to get superhuman performance on a game. They use neural networks to learn value functions, and it's just amazing how that idea is not new, but a lot of progress. So this is on backgammon. I think some people here have probably played this, but not a lot is new. And then you go for a long time, and there's a whole deep learning revolution, and these things at the core of reinforcement learning are still often the same. And today we're talking about things like RLHF, this reinforcement learning from human feedback, which has turned into now just talking about just reinforcement learning generally, and kind of contextualizing this transition from ChatGPT, which was about RLHF, to what we were talking about now, which is just this RL training for reasoning on verifiable outcomes. It's like, how did RLHF actually become a thing? There's a 2018 paper here, which is kind of proposing the idea of reward models as something that can capture complex human values and can be used to study in a large suite of different machine learning systems, and this quickly got applied to NLP. The kind of canonical RLHF reference, the Cristiano et al., is actually for control of simulated robotic agents. This is a really great paper to kind of understand what some of these seminal figures were thinking about. It's like how we can capture such complex signals as comparing two things that might be hard to really generate a good answer on, and then have machine learning systems kind of incrementally improve their performance on a variety of tasks from this. It really quickly evolved, and then from the actual ChatGPT announcement, we can read this benign quote that's like, we trained this model using reinforcement learning from human feedback with the same methods as InstructGPT, with different some subtle changes that they don't tell us. And really, RLHF was necessary to go through this door of ChatGPT style models that we're all used to using today. It really wasn't sufficient, and it wasn't the leading thing that people were thinking about when they're talking about language models in the last few years. It was really just a cherry on top. And now we kind of have this bigger RL phase where this is a great meme to kind of get us older RL researchers interested. Is like, RLHF was this really necessary thing and very important, and then how did it come to be that RL actually becomes even more important to this AI ecosystem again? So when RLHF came out, I think the community spent a year plus really figuring out how to implement good open source tooling that works on language models with RL. I would say that ChatGPT came out end of 2022, and pretty much all of 2023, and to this day, there are very few models that are actually trained with RL for this preference learning problem that was originally introduced for. So most of this time, RLHF was building this really nice RL infrastructure for language models that made this explosion of research that we're seeing today. I don't talk about a ton of these blog posts and papers that are coming on RL training and different subtleties to doing that for reasoning. But without RLHF, this takeoff that we're seeing in an academic sense would really never have happened. And a lot of this story is also just the kind of funny way that things happen in machine learning. Training on verifiable outcomes like this O1 and DeepSeek R1 was really not new to the field of AI. Here's a series of papers from 2022 to 2024 with some type of reasoning training that requires checking the answer for the work. There's things like self-taught reasoner, Vine PPO, training RL with code execution feedback. All of these ideas were in the academic literature before O1 was released, before DeepSeek R1 was released. So it's just the way things happen is that timing is really important, and things can change really fast when there's so much investment in the area. And then this kind of O1 blog post, September 12th, was when it's a paradigm shift in how people see the validity and value of different methods, even though not a lot has had changed in the literature, but these new language models trained with RL to perform complex reasoning, paraphrasing what OpenAI said, have changed quite a lot. You can visualize this in different ways. This is from when O3 was released, and Riley Goodside plotted the ARC AGI scores for various OpenAI models and put them over time. And this is what it looks like when a paradigm shift happens. And we solve an evaluation overnight and just need to rethink kind of what is the challenge that the cutting edge of the field is going to be looking at. So I'm going to take the technical portion of this talk and kind of talk about like, what is this RL training? How do you think about reinforcement learning on language models relative to the classical definitions of RL? Shout out to Sutton and Bartow for winning the Turing Award. Could have put a slide in there for them, but I didn't. And I think if you're looking to learn this, that's still the place to start. They have a great textbook that's on my desk. And before doing this, I'm going to kind of explain more of post-training. And one of the takeaways for this talk is kind of a lot of post-training is no longer in vogue. RLHF and all people are talking about reinforcement learning for reasoning. These models like DeepSeek and R1 are doing all of these techniques in a complicated pipeline. The reasoning stuff is the new hot thing, but you really, if you want to train a leading frontier model, you need to do all of this stuff. So that's kind of how complex technologies are pushed forward. You keep building on what has come before. So there's many different words that you can describe post-training with. Allen Institute, we use language model adaptation, which is really going to say that we have a really strong pre-trained language model on large amounts of web text, and it's not really set to do any one specific task. It's going to be a fancy autocomplete. In reality now, these base models are exposed to instructions and other things, and you can really use them in a lot more interesting ways than GPT-2 era base models, which were very sensitive. And what you do is you take these and you come up with a list of tasks that you want the models to be good at. You want to be able to answer questions. You want to have them be useful at writing really useful code and solving math problems. And you kind of identify this, and then post-training is the way, the art and science of actually pulling this out of the language model and getting them to be really useful in specific things. Back in the era of InstructGPT and ChatGPT, this was a quite simple process where you kind of had your base model, you did some supervised fine-tuning or instruction tuning on some human-written instructions and answers. It was really human-heavy at the time. And then you would train a reward model and do reinforcement learning from human feedback. Kind of this really forward pass and a lot of human data. And it worked. It got us to ChatGPT. But yeah, this is mostly what I said. It was kind of seen as a three-stage process. You look at the InstructGPT paper. You look at a lot of early blog posts and things on RLHF. You'll see people to say it's a three-stage process a lot. And that's definitely fairly outdated. It was a three-stage process. And now it is a much more complex process where you're addressing more capabilities in your data. The evaluations that people are saying when they release a model are only a subset of the things that they actually care about, both for their users and internal applications. And the shift from using human completions to synthetic data is extreme. So the language models are much better at answering almost any code or math problem than an annotator that you can hire. And the annotators are really being pushed out into the fringes of trying to get new data for really niche capabilities and things that the models don't know how to do today. But this gives us kind of a very different pipeline. You can see this is the figure that, for people that were chatting earlier, I referenced the llama figure. And you get a lot of, if people like, if ChatGPT had one of these system diagrams for post-training, it would definitely be far more complicated. And it's just, it's a many-staged process with lots of data sources and kind of this human evaluation that can be also used as training data with multiple loss functions. So saying that you're just doing post-training, it requires a lot of like, okay, how are you actually doing this? What are you prioritizing? You have a lot of tools you could use. What are the ones that you're going to focus on? And kind of you can visualize this if we use my same block diagrams. There's kind of more feedback loops, there's more steps, and there's kind of this idea of an intermediate stage where you'll just kind of keep training your N+1 model and keep making it a little bit better with different loss functions, different data, and so on. And you can see some model references if you want to find various papers on explaining these processes that were used. And I like to summarize this as now we kind of have three tools in our kit for post-training as different loss functions and different types of data. We have supervised fine-tuning, also known as instruction fine-tuning. This is where you have a prompt and a completion, and we're using this autoregressive loss function to get the model to predict those tokens more accurately. And this is really good for teaching format and kind of the base of following question answering abilities. And kind of this teaching formatting and thinking about what this autoregressive loss function would be doing is really good as we contrast these next stages, because the optimization techniques get more open-ended and more flexible for the model to kind of fill in what it actually should be learning from the data or signal that you're showing it and the loss function that you're using. So then we kind of have these preference fine-tuning and reinforcement fine-tuning. Preference fine-tuning is a generalization of this reinforced learning from human feedback. You have this pairwise data, and you use a contrastive loss function, which can either be something like DPO or some RL function that's prioritizing a reward model, which is just very different than predicting the next token in the sequence. And this is a very rich area. I think preference fine-tuning has very much been associated with like a narrow layer of style, but a lot of recent papers show that you can meaningfully improve performance on math and other things with this type of loss function. So I would expect that, and I'm like invested in this kind of idea of RLHF continuing to be pushed in the research field and in kind of industrial practice. And a lot of people will kind of underestimate it for the time being. But that's not to say this final one, what brings people here, the reinforcement fine-tuning, is also like, it's credible that this is a moment of focus, because in many ways it is so easy to boost performance on tasks that people care about with this reinforcement fine-tuning. And I'll explain what this is in more detail in RL technically in just a couple slides. But really just to double down on this point, what reinforcement fine-tuning and these kind of new methods are doing is, I talked about pipelines becoming more complicated, and DeepSeek R1 and OpenAI O1, and especially if we look at things like what has been rumored with GPT-5, where they're like, it's just going to be one system. Like, there's a really big reconfiguration of how many steps and how complicated it is to train one of these models, especially in these reasoning and post-training stages. And RL is taking a much bigger amount of the attention in compute, in acquiring new data, in interpreting the importance of the results. Okay, so now the technical portion starts. We're going to look at reinforced learning basics. I hope many people have seen some sort of diagram like this before. Reinforced learning is really motivated by some notion of trial and error learning or sequential decision making in uncertainty. Both of those framings, when you think about using a chat model or a reasoning model like O1 or even ChatGPT, are like, okay, how does trial and error learning or sequential decision making get folded into these kind of basic question and answer tasks that you're doing? And we'll break this down, but really these notions of an agent that takes an action in an environment, and the environment gives a reward, have been very contorted with language models to be a kind of weird corner case of the potential setup. So if you at least think about this in language before we get to the actual way training is done, the agent is a language model, and when you ask the question to the language model, that question is the state that we are modeling, and the answer that the language model gives is an action. And the target environment doesn't really exist. I think most of this training that we're doing, we're not modeling the human. They don't have, they probably experiment with things where language models are talking to each other to try to enable multiple tasks. But for most part, it's just a question and then an answer. There's no environment other than a potential reward model or something to check if an answer was correct. So if you take that, what I'm saying is it's like not really that much of an iterative process in terms of multi-turn questions or anything like this. You pull a prompt out of your training data, you get a completion from a language model, and then RLHF is you grade the completion with a reward model, which is trained on that pairwise preference data, and then it gives a reward that you can then update the agent on. You do all this in normal machine learning things where you have batches of data and it takes a while to train it, but to simplify it, this is what standard RLHF would look like. If we're to expand this in the technical level, I think there's a lot of, the most common word you would hear for the last few years is PPO, which is proximal policy optimization. What this is just some RL algorithm, and if you actually want to implement this with language models, you need to have multiple copies of language models. So you have a policy model, which is what actually is generating the text you would read. you have a reference model to help constrain the optimization so that you don't end up just generating gibberish, and then you sometimes have a value model. I think if you were to hear about GRPO, so DeepSeek's group robust or group R, group R policy optimization, GRPO, they essentially have a different way of approximating value that doesn't actually need a learned model. So you just look at the answers relative to your batch and if they're right. But this is kind of a standard reinforced learning setup if you're going to do this with language models in any task. You have to have a bunch of copies of the model, and then in RLHF it goes to a reward model as well. And then if we were to think about transitioning from this RLHF era of language models to something where we're looking at a verifiable answer, the simple idea for a researcher is, okay, like let's add a ground truth reward to the model. Let's give the model an extra bonus on top of the reward model if the answer is actually right. And this is what what we first tried when we were training our Tulu models. And really, what it turns out is the thing that is used for DeepSeek is what we do at AI2 is like you don't actually need reward models for all these math and code problems. And you just take a prompt, you generate an answer, and you have some checker to see if the answer was right. And then you do this RL loop, and that simple thing of language model answers a question, check if the answer was right, update based on long literature of reinforced learning policy updates. The models get better at a ton of things, and there's not a lot of downsides. In terms of starting to implement this on our models, it's very much like, oh, that wasn't so hard. It just kind of works. That wasn't a whole couple months of rabbit hole. We just kind of tweaked our RLHF recipe, and it was potentially easier. So if we kind of zoom out, what we call reinforced learning with verifiable rewards is this loop, where you have a language model, you still have the reference model, so there's still some stuff buried in here. But it's really just checking if the answers are right, and then updating with this reinforced learning loss function that has been around for a long time. So this is something that is really nice because it is so simple, and at the same time, this sort of talk kind of, I mean, I don't know how things like DeepSeek exactly are trained because all the details on data and making the infrastructure really good are really complicated. So it takes a lot of engineering effort to have all that data, to know how to put it together, and there's things that you can draw on from past RL literature, and it is the thing that is complicated now, and I'll cut myself off before I say emerging research things that are TBD and if they're actually right. And the core of these things is the data, and OpenAI released this reinforcement fine-tuning API, or they didn't release, they announced an API in the fall, and they gave this example on data, which is like a biology example, which is unnecessarily confusing when you can do a math example. But really you have a prompt and an answer. And an example would be like this math problems. It could be in our training data for our next model, so just like a big, like what is this multiplication thing, something that we could all do but don't want to, and you have an answer. And this is the type of thing that you can train a base model on, and it'll like learn to have chain of thought. And it's pretty wild, but like that's all you need to give a base model. And you need to have some distribution of it, but it learns to do intermediate steps. The answers it generates are much longer, and we're gonna dig as a community into this and like what actual data you need to extract all these capabilities, but there's a lot of open fields by which we can explore. Some examples you can find in our Hugging Face. There's also clever things like more textual domains where you can say, write me a poem about a goldfish, and then you can add a constraint that start every sentence with the letter G. And that is something that is also verifiable. It's less obvious than math, but still very intuitive. And the sort of thing that people are going to keep pushing these training techniques into to kind of create things that are like, adding constraints like this on text is really useful for people using models. You like want a model to respond in a really specific way. So it's not just math and code, but math and code is the obvious hill to climb on. OpenAI referred to this as the blog post as grading functions. I have an example on the right, which is like what the code is handling here when you're doing answer extraction is all the various ways you can express the same answer. I expressed 5 different ways that you could express the same number there, and language models effectively get tuned down to their own way, their own common language. But the important thing to think about from this slide is what happens when you're doing math and code and precise instruction following all at the same time. You need some rubric or way of reward shaping these different inputs to the model at the same time, so we can learn at everything at once. And that's kind of a classic deep learning problem, which is like you need to make sure the model is learning everything. When it was just tokens, when you're predicting the next token, that's pretty easy. But in this RL sense, where it's going to be, we need to balance the amount of problems in our batches so that as we do this long training curriculum, they all kind of finish learning at the same time. There's definitely flexibility in that, but there's a lot of there's going to be art in understanding how we should shape these rewards and how we should shape the data set for when we're training on verifiable outputs. If you've done RL training before, you've seen a lot of curves that are supposed to start, and there's a time x-axis and a score y-axis, and it's supposed to be that it goes up, does its little arc. And really, when you're doing language models with this verifiable rewards, it looks a lot like this. The three plots here are KL, which is the KL distance, which is essentially how much the model changes relative to the base policy, and then two representations of reward. The middle one includes the KL penalty, is the only difference. So the last two are really similar. And what this plot is showing is a variation on how big the KL penalty is, but the real takeaway is like this looks like very normal RL training when you do it. And if you've been playing around, especially in RLHF and other post-training before this, it's like, it's a lot of it looks very simple, which is a lot of why I'm optimistic about it continuing to get better. So this is a basic like hyperparameter sweep type thing, but we've also found in practice you can do funky things and keep getting performance. So it's these three curves, three colors are three different RL runs where we kind of took what you can think of as like an instruction model, an SFD model. And then we did RL 3 times, and we just wanted the numbers to keep going up, and they were. So we like did RL, and then you reset it, and then you do RL again, and reset it, and do RL, and do it, reset it. So this is kind of like saying the funky things that I was saying, where you can just get most of the way there by just thinking you do like one thing and one other thing. But when you start to just embrace kind of a bit of chaos and controlled chaos with maybe changing the data, you can keep getting more performance out of these methods in kind of not intuitive ways. So this was for our OLMO2 instruct model, either 7 or 13B. At 13B, it says on the bottom. So there's a paper for that. If you can't find it, please reach out. But it explains this plot in a bit more detail. Another example is for our kind of general post-training recipes. For this like 2-3 8B model, all we did was switch from this PPO algorithm to the GRPO algorithm, and we got like a very meaningful eval shift using the same data set, the same starting point, and it's just like, it's hard to express. Like, for context, the original Tulu project was about 4-month project with like 20 people, and this sort of 1-point gain is a very major delta in the like relative impact of your project. So for us to just change the RL algorithm and not change anything else about our pipeline and get this level of improvement is a very big deal in research. This is the type of thing that's like an easy change that makes it the difference between anyone caring about your model and not. So at the cutting edge, to have that type of performance improvement is really an optimistic signal. And it's the sort of thing where I'm like, there's so much low-hanging fruit in training these models. It's if you just incrementally try things from informed priors, you're normally going to find improvements in your evals. And I don't know if there are people, it's an NLP master's program. I don't know if there are RL people in like deep RL background in the audience, but one of the most common critiques when we get when presenting this kind of language model RL work around is that this is not new, and it is just like classic RL, which is just give the agent a reward, a sparse reward when it does something right. And it is. I think the innovation here is kind of stability of implementation and making it really easy to do without degradation outside of domains. So when we train on math and code, it's not like the model gets worse at general chat abilities or anything like this. Even sometimes it like fixes the model and makes them a little bit better. So there's a lot of weird stuff with this RL loss function, but it just being so easy to apply and stable, largely from this major open source infrastructure work from RLHF to kind of get all the bugs out of the way, is why there's so many papers on this right now. And there's a lot of questions relating these two things. So I've talked a lot about RL training, and I also motivated this by O1 and inference time scaling. And this is the plot that OpenAI released that collectively nerd sniped the entire AI field, where they showed this kind of training time compute and test time compute. And largely, the point is that RL training and test time compute are really complementary things, and you can kind of see a complex relationship forming between them. And really, this reinforcement learning training can improve scores dramatically without touching the inference time compute that we're showing here. So in all the results that we talked about for our post-training recipes with Tulu, the sequence length going up is not really something that we've done publicly right now. But at the same time, when you look at DeepSeek R1, it is the same loss function, and the sequence length is an important marker of some pieces of the RL training. And really how I phrase this is that the RL training is the most popular way of doing inference time compute right now, but in a lot of ways it's natural to expand that. I think I've learned a lot from Dylan on like how brutally expensive long context inference is. And if you're going to do something like best of n, you can actually scale your inference much better because you don't need to do as many long context inferences. So this is something that I'm trying to form more opinions about, but I look at things like O1 Pro and stuff like that, and I'm really optimistic about not just this RL training for inference time compute. So yeah, so this is kind of a summary of the same slide with less details, where it's like there's just more science that people are talking about this parallel inference time compute region in addition to the RL training. The one that if you want to read more about, I think the Claude 3.7 blog post was really nice on kind of talking about why they're exploring it and why they didn't include it right now. So I'm going to kind of go through some of the recent models. I've been writing a lot of blog posts on this and just kind of share my worldview and how I kind of process releases and how I think that a lot of people in the audience could benefit from it. I think as a researcher, my prior is trying to understand where the field is going. And I use the models, but if you're an academic or student, like your business bottom line is not about whether or not you need to use the right model at this instant. It's more of like, how should I make decisions on where AI is going to be in a few years, and how do you make bets based on that forecasting? So the one that kind of reignited a lot of interest in AI broadly and RL specifically was DeepSeek R1. And really this is about having the recipe for people to build on in terms of training these reasoning models and to have the actual weights to do things like distillation. Distillation is where most of the work will be, which is when you take the DeepSeek R1 model, you generate completions from it, and you do some limited post-training on a smaller model. And a lot of people will do this, but their long-term, more like accelerationary effect is that everybody is really confident that you can do this four-step pipeline with large-scale RL and make a model like this. And they have a lot of cost numbers on DeepSeek V3. Those are complementary to what's seen here. It's with an efficient team, you can train models pretty effectively, very effectively. And that really confirmed a lot of the rumors about OpenAI O1. And people have said this a lot, which is like the yin to DeepSeek's yang or whatever is Grok 3, which is like having a lot of compute really still matters. And Grok was founded like 19 or 20 months ago, XAI was, and they have a state-of-the-art model. I honestly feel like I under-index on it, mostly because it's a new interface. They have to go to the model and form new habits. I think the lesson is to be very open-minded and try to use AI tools that you are not as used to using, and to actually actively go out of your way to try some of these new models that people are talking about. It is a cost in time, but it really helps you extract the potential productivity from the best models. And a lot of the Grok release was around this idea that Grok was supposed to be based and things. It turned out that in practice it wasn't as based as they were advertising, but it expanded the window by which people would think that model personalities could exist. And it kind of, they really are in the conversation with OpenAI, Anthropic, and Google. And there could be more companies that do this. I think there's a lot of other companies out there that have very substantial funding and very substantial kind of talent pedigree. And AI is not, it's not defined who will have the best models and who will have the experience that people like. even though they're kind of have been key players for multiple years, it's very exciting in this way that a new player can kind of just join what is happening. And when there are more people and kind of the race is expanding in that way, it's kind of going to make everything go faster because there's more competition before a kind of potential slowdown and consolidation when all the economic things kick in and risk becomes more real. Also that this model, and we'll see this when I talk about Claude on the next slide, search and optional reasoning or reasoning of some form are becoming an industry standard. I think one of my most common use cases of ChatGPT particularly is search. I think they're doing a very good job, and trying to compare how the different models use that is very worthwhile. With XAI's release, kind of opened another evaluation rabbit hole for models. XAI did not release a ton of official numbers. These are the official numbers on the left from the live stream, which are on reasoning benchmarks. The text is really small. You don't really need to see the scores. When Grok was released and publicly available, it was the top performing model. The asterisk is that it's top performing based on some added inference time compute. All of these models are doing inference time compute in a different way. The OpenAI blog post kind of famously had some shading, and there's something like they do majority voting at 64 samples. There's also the confounding factor of we don't know like how many tokens they spend on thinking relative to their answer. So all of these inference time compute announcements are going to get far messier before they start getting cleaner, because with RL you can really scale the amount of tokens it spends on an answer, and you can also do things like parallel test time with majority voting, what is going to turn into kind of bespoke verifiers for each model. So I think that's like likely where O1 Pro type things are going, and comparing that is extremely hard. I think it's really quickly going to not be an apples to apples comparison, and one of those things where you need to figure out your own use cases and kind of talk to a lot of people that are using these models. Then Claude joins this conversation. The thing that, in many ways, this Claude user interface is closer to what Grok has been doing, where they have a button that you need to click to get more thinking power. DeepSeek is also like this. It's just that the DeepSeek R1 model itself was so popular, but in the app, if you use DeepSeek, there's a thinking button that does the same thing. I actually have been thinking and writing a lot that I think having to select thinking manually is a very bad user experience, because people are figuring out what they use AI for, and it's not really clear if you don't know what you're using something for when you should have the model try harder on the task. It's a very abstract notion. At the same time, Claude is going to get search. So it's like these are the user interfaces that we have, which is you can spend more on compute and you can get outside information. And that's like, it feels like this kind of imperfect thing that we're going to move through, and it's really like how does all of this get synergized into one model? In some ways, this is kind of related to this just being a rapid hill climb on the generation of models that we have. Dario Amodei, CEO of Anthropic, said that like most of the progress has been through post-training in recent years, or in recent months, and he was talking about this Claude 3.7 model, and this kind of leads into what we're talking about last, which is going to be the GPT 4.5. So there's a GPT 4.5 was kind of received in an odd way. I think watching the live stream and reading Sam Altman's tweets around it are really, really weird, because they're trying to make it a low-key thing while simultaneously being the biggest model that they've released. We don't have exact details, but approximately an order of magnitude more compute than the GPT-4 model. It's a good exercise to look at the costs for various new architectures of OpenAI when they are released relative to the peer model at the time. So the GPT 4.5 model, when it was released, I think the API pricing, if the API might not be available yet, is like $150 per million output tokens, $15 or $30 per million input, and GPT-4o is like 30 times cheaper right now. But at the launch of GPT-4, it was something like the most expensive version with the longest context. It was like $30 per input million and $120 per output million. So the prices that we're seeing now are not extraordinary relative to where they were just 2 years ago for the newest architectures, and they just keep getting driven down, down, and down. And that's the sort of thing that people fix on is price, and that's mostly because OpenAI was just talking about like EQ and this personality and reduced hallucinations, which are really hard for users to pick up on. The emotional depth thing that people have been doing is finishing green texts, which I've done a lot of these, and they're very funny. There's weird things where it feels like the model is referencing your past chats to know about people that aren't public figures, because the date cutoff was supposedly still in 2023 for these models. So it's not really clear exactly what OpenAI is doing in ChatGPT with that regards, but these have been good. It's like you don't have to cherry pick them. Like the model does do a good job at this task. And mostly why I'm excited about this is that base models really unlock a lot more in post-training. If we're thinking about the Claude release, where the CEO is like most of these improvements are from post-training, it's like they really haven't needed to move up this level, but a lot of recent progress kind of shows that you can pull capabilities out of with post-training. We've talked about doing really basic math problems with RL, and you get this chain of thought and this kind of generalization to more mathematical reasoning tasks. So I would say that we kind of need the infrastructure to train and use this GPT 4.5 model fully, but everything in the industry points that this is the direction that it is going to use these bigger models. I mean, XAI, we don't know how big Grok is. It was probably previously the biggest model being served to users. And Claude and Anthropic have insinuated that Claude 4 is going to be well larger as well. So there's kind of this debate where we go from NeurIPS and is this the end of scaling as we know it to bigger models are still very impressive. And I would say the evidence will probably hopefully back me up that these bigger base models provide richer platforms where post-training can extract more performance from them over time. But you need very sophisticated infrastructure to actually do this on a model of GPT 4.5 scale. So this is probably the best plot in terms of performance for GPT 4.5 relative to 4.0. The lower circle is 4.0 on GPQA, and the upper is GPT 4.5, where all the other models on this plot are reasoning models. The reasoning models are benefited a lot on GPQA, which is kind of like a really complex STEM question answering domain. So if you ignore the reasoning models, the same type of training, which is just a general chat instruct model, scaling up has given dramatic improvements on kind of what is seen as one of the core benchmarks in the field. So if reasoning had not happened, this would be probably the biggest step in evaluation scores that we have seen in months. So like the reasoning explosion has desensitized a lot of us to major steps in some of the evaluations that we care about, which is probably more fun and exciting, but it's fun context. And related to this big model, there's a quote from the DeepSeek paper. It's small. They said, while distillation strategies are both economical and effective, advancing beyond the boundaries of intelligence may still require more powerful base models and larger scale reinforcement learning. So this is one of my pieces of support for understanding that it's much easier to pull performance out of a strong base model than it is to, with kind of instruction fine-tuning, teach them to solve really complicated tasks. Because this instruction fine-tuning is one token at a time, it kind of makes sense that this complexity would be much more handled much better with these kind of more general loss functions where the model can kind of learn and explore in its own way. Okay, so I'm almost done. This is kind of the provocative part of the talk, which is like, what does it mean for RL to be the focal point of language modeling development? And it's like we've talked about this a lot with the acceleration of performance on key benchmarks, but like how does this expand to generalization? And like if pre-training is much slower, like what types of data can we pull in? So some of us have talked about this before the talk, but OpenAI is saying that they're pretty much throwing RL at every one of their important public avenues, from deep research being trained with RL for some internet browsing task to their Kua operator model, which is a GPT 4.0 model, being trained to navigate the web with RL. We don't know the specifics, but it pops up a lot. And one of the ways that I draw this in is with the bitter lesson, where Rich then essentially had this essay that really highlighted the fact that most research ideas that win out in time are those that can be scaled simply and don't have unnecessary kind of human priors in them. And the methods that he highlights in this essay are those that kind of combine search and learning. If we look back at deep learning, it's a pretty obvious analogy that deep learning has been immensely successful at kind of just scaling and processing lots of raw information. And this new reinforcement learning training is, the model is trying multiple completions to a certain prompt and getting really sparse feedback on this. So it is a form of search during training that is very general and hopefully can continue to be scaled. So this essay is, if you haven't read it, is 100% worth reading. He also has an essay on verification, which is very complimentary, especially as we talk about whether or not these reasoning models will generalize. So this is when you change the theme on a slide to change the footer, all the text boxes get resized. So I normally miss one. But this is a pointer to the fact that Rich has another essay on verification, which is also very old, and it's just the kind of thing of, he has been consistently right on a lot of these ideas and what can unlock continued performance in machine learning systems. And there's a lot of analogies to what's happening now, where we have media covering research blog posts from many universities as major technological breakthroughs. It feels a lot like the alpaca moment, but kind of because what I talked about with infrastructure existing in the way that it is, it's going to be a kind of much more tangible and sustained version of progress relative to when these first chat models were coming out, which were just kind of limited fine tunes on some human data to kind of mimic ChatGPT. And then, nope, I lost that screen, that's fine. So it generally went back to this. We said that RLHF was necessary but not sufficient, but this kind of RL could be where all the labs are investing all their resources as they continue to try to improve the performance of the models in really meaningful tasks. And the kind of thought experiment is like, what if this kind of post-training idea? So right now we're stuck with pre-training and post-training. And what if post-training can be just training, where we have a kind of gym of countless tasks from robotics to math to code to biology, where the models are trying some sort of action in the world and getting feedback on what is happening and continue to be trained in the domains that we care about. This is obviously a existentially expensive and hard question for AI, but it kind of opens the door to, we're actually training on tasks that we care about. If we can verify them, we have a format where the language models can take feedback on these types of actual specific questions rather than just general text. So to the extent that this ambition can be true, it would be very fun to kind of keep driving meaningful tasks, but I would not bet on this actually being successful. It would just benefit me if that was the case. And this is like kind of a sort of rough ballpark, which is, if you look at the DeepSeek V3 paper, it's like well less than 1% of the compute in GPU hours was on post-training. And there was a tweet that is now deleted where a member of the team said that DeepSeek R1 took a few weeks to train, which is this large-scale reinforcement learning. So even if you just take this few weeks on the same cluster, it would already be such a huge increase in compute. I think this is obviously not a comparison that you can use in any sort of meaningful argument, but it is directionally where the field is going. And if you kind of keep thinking about this, and if there is just one internet to train on, it is a fun proposition to kind of keep scaling where we're going and kind of see the limits of it. So these insights and the few actual technical results I shared are built on a large team at AI2, and a lot of them are pictured here. But thanks for having me. It should be a fun time to be an RL or an AI researcher, and hopefully it's a little bit easier to make sense of what is going on.
Thank you, Nate, very much. We have, I think, maybe 10 to 15 minutes for questions, and then we'll be taking a short 10-minute break between speakers to get Dylan set up and going on the camera, on the computer. So if anyone has any questions, I'll throw a mic to you. Start with Cal, and I'll move the mic around.
Yeah, so during your methodology kind of slide, and you were talking about what you do to stay on top of things, do you have any like sources of information you're constantly looking at? Is it just conferences, or are you kind of doing a large scale search of the internet when you do these things?
I think that I'm in a lucky position where it's mostly pruned. So it's a mix of a Twitter feed, but I don't have to be too scrolling for too long. And then my paid subscribers have access to a Discord. It's not not saying that you have to pay. It's like if you can't afford it, it'll give you access. But it's generally it's a community that is willing to like try to curate a high effort community and people share and discuss things there, and then also like having a job where people are trying to stay at the frontier of AI and they discuss these things. So I would say I get a roughly uniform amount of news there, but most of the news you largely ignore. So I definitely read fewer papers than people expect, and all of this, and it's like there's a very narrow number of people you actually have to listen to and be able to like understand what they are actually saying.
Cool, and just to follow up on that, do you have any recommendations for us as students or kind of younger researchers trying to find this information?
There are things like I have a list of Substack recommendations on my blog, which are things that I at least read sometimes and think are good. There's that path. And then it's just like being curious. I think that it's not necessarily the case that everyone that is a student should be trying to keep up. I think most students should actually not be trying to keep up with everything, because like that is not, like your cutting edge is to learn skills that are useful for building things, and then it is a certain number of businesses that you actually have to make like game time decisions on what is happening. So there's kind of balance of it's fun, but you don't actually have to. But normally I err on the side of students are trying to plug in more than is beneficial.
Cool. Thank you.
I'll walk over to the back and then I'll get the front here. As I'm walking over, totally unqualified opinion, but there's a guy on Twitter named Swyx, S-W-Y-X, and he has a high signal AI list on Twitter that can get you started if you want to burn your time on that.
He also has a good newsletter. The daily newsletter is good.
Too, I think.
Yeah.
Thanks for your talk. Two quick questions for you. Hopefully this is not overly technical. One of the things I was wondering, I think you'd be probably well qualified to kind of talk about this, but I was really wondering, in classical RL, there's kind of this problem of reward attribution. How much does pre-training actually kind of address this problem in like language model RL, especially with huge chains of thought with reasoning?
Honestly, I feel like I should have, you can come ask me this after as well. I don't have a good answer. I think it's mostly that the language itself, when it's organized, just does a lot that makes it flexible to be used in a lot of these domains. I think we're leaning on the representation of language, and when you think about reward attribution in the RL sense, it's much more complicated with this multi-turn sequential thing that we're not really doing. So I think for an agent that's taking probabilistic actions and then it takes 100 actions to get to one very sparse reward, I think attribution is a much more interesting problem here, but we're kind of jerry-rigging language to guide us to like one really specific thing, where especially when it's autoregressive, it's like I think it's still somewhat segmented, but it may become more overlapping.
I have a promise, Darian, I'm going to come up to you, but first, thank you.
Oh, thanks. Actually, I have a quick question. I see you mentioned about AI infrastructure and inference for that. What do you think currently the AI infrastructure lack of for the training and inference, aside from the ability to process larger and larger models?
Can I just make you wait until Dylan talks? It's different. It's just different ways that the infrastructure is tested based on the training regime. So I think it's like they all have this trade-off of memory, flops, and one other thing. There's like the three things that Dylan always mentions. But what is happening is like long context uses a lot more memory. And for example, there's GPUs that have more memory, but they have fewer flops for memory. So it's like you can fit a bigger model in, but you train slower. And then the third thing is like communication speed. And then essentially you have a co-design on your cluster between how big of a model and how fast you can train it, which is based on, and like the architecture is based on the communication protocol you need to have between nodes. So they all work together to end up like you're trying to do experiments faster or train bigger models or more specific models, but it's like you can't push a specific direction without improving the infrastructure.
That's very insightful. Thank you.
Darian, as promised, and then I'll get Jeff afterwards. So.
I was just curious. Well, thank you very much for the talk, first of all. But I know that like in a lot of like video game-based RL, there's been a lot of work to deal with the sparse reward problem by like defining sub-rewards and like a lot of reward engineering. Do you see that NLP RL field is going more in that direction, or do you think these rewards we have as just like whether or not it gets the right answer and stuff like that are going to be sufficient?
For the questions we're using now, it seems like, or like for the problems and domains we're using now, it seems like the outcome is sufficient. And the support I have for this is the kind of papers that show like sampling baselines to models without doing any RL training. So they look at the rate. If you ask the same model the same question thousands of times, you look at the rate of the correct answer. And even like extremely outdated and small models like Pythia 70 million parameters will generate correct answers to this like math, like all caps, like math 500 data set a reasonable amount of the time. And if we're trying to just like reinforce the ability for it to do that, it's very different than like a randomly initialized neural network trying to find something like that for the first time. So as long as we're in domains where things are close, I think we're gonna hill climb on that really fast. But then it kind of opens up the same question of like how do you get AI to solve kind of unsolved problems that exist already.
Thanks.
Yeah, thanks for the talk. It's really, really amazing. So the transformer model is like it's really, really parallel to train, right? And so it's great for pre-training. It's not so great for inference, like the way that it's designed is just not very parallel in that regard. And you know, because it has to generate step by step. And so if we're scaling up this RL like a ton, do you think that that's a problem with the RL problems, or like is it just you can parallelize those across different things, or like is that a limitation of the transformer, and should we look at different architectures, or is it? Yeah, what are your thoughts on that?
I think it's a good type of academic problem. I think it's like the type of problem where you're like, oh, it's like, can we do something that like really makes people readdress the certain paradigm? I thought you were going to lead on to like, oh, the diffusion language models do better because they generate really long context involved inference for like a fixed inference cost, which is a fun question of like, can you train diffusion language models with this RL and not have as many infrastructure problems on long context inference? But it's like, it's like a fun experiment, and I definitely don't spend most of my time thinking about this type of thing.
Cool, thanks.
Anyone else? Oh, yeah, the back. Ian. Yeah, time. We'll do one more maybe. We'll do Sid next, and then we'll be good.
Okay, thank you very much, an awesome talk. I spend a lot of time thinking about confidence. And so when models are generating token sequences, I would really like to know how confident are they on the next token. And there's been a wealth of work in that area, even computer vision, speech recognition. But in the NLP world with the large language models, there's not much there today. And what is your sort of impression or feeling about how the importance of just outputting a sequence of tokens and having base models and using reinforcement learning to reduce the likelihood of hallucinations, let's say, compared to outputting additional information about the confidence of token sequences as you're generating them?
I think you kind of asked or you proposed it as a very important direction, and then you asked like two specific-ish questions. And I do think that people are using RL for factuality, and I do think that it is a way to help address hallucinations. It's a kind of complicated way. It's a lot of like back scores and context, kind of have that in your training thing. And then it's almost like a product question with whether or not you want the model to have really high confidence or to actually just output whatever the confidence is. And I think that generally I lean towards the former on having the models that can understand their confidence is such a huge unlock in a product sense. If you think about when you don't like using models, it's mostly because they just say gibberish. And if the model really knew its confidence all the time, the ability to just have like a calibrated answer with its level of uncertainty would be so wonderful, where it's like the answer is blank, or it's like, I'm like iffy, or like I'm just totally guessing. Like I'm gonna blabber as a language model because I can, but here's some tokens you should go text. Like I think as a user that would be such a huge change. And people talk about scaling, like improving the calibration of models in factuality literature, but I think that it just needs to be. It's almost like when the field matures more, then people will be like, okay, we really need to make these more robust, but it would be transformational.
Cool.
The RL
I agree
factuality
with you
stuff
on that.
is cool.
And today, the models will always sort of articulate their confidence on something, even if it's not there. And the second question, which is sort of orthogonal to that, is in a lot of the early search work at Google, etc., using neural networks for ranking of pages, they were actually using feedback from user clicks to update the models there and then. And do you see sort of a pathway of going from reinforcement learning that's done today to online systems where if there is an error and I correct it, and if you trust me, these models can get improved online sort of over the lifetime of their usage and just become better through being used?
I don't actually think parameter updates are going to be done online,
Yeah.
but there's architecture changes with knowledge stores that you can kind of sub in, or context that I think people will change. I think ChatGPT really heavily relies on context now. If you're doing GPT 4.5, it's like a little too strong. If you're used to using just like a vanilla model and you go to ChatGPT now, it's like you don't need to tell me that you know about my life. But if you think about that in a more general way, where it has like a general context that it's updating, it can work. It's just not something that's being focused on.
That's very cool. Thank you.
A lot of the RLHF literature is downstream of this preference stuff that Google did and stuff, which is fun.
Okay, we'll do one more with Sid, and then if you have other questions, you can maraud Nate in the 10-minute break we'll have afterwards, I think.
Thank you. So my questions are on long context reasoning. So at least in 2023, when I was writing prompts on 3.5, GPT 3.5, even though it had a 16K context window, it would barely follow like the first 4K and the last 4K tokens. So because of loss in the middle, which is the paper by Meta. So like 2 years down the line, I hardly hear papers addressing this as a problem. Is it because the direction is reasoning models would eventually solve the problem of long context reasoning, or is that a problem that people don't think it's important enough right now?
I think there's a lot of, I mean, it's like, there's definitely still a lot of focus on long context. I think it's like one of those problems where it's not necessarily easy for people to work on. It's a lot of hard data work, and then even more expensive to train your models than it would be, because most people don't train their models for long context in research. So I do think it is still, like I would say it's still an important area of research, that there are papers that come out that are very important. So I think that they are getting better. I think it's hard to know. I don't know if anyone here does, but it's like ChatGPT, when you pay more, you get longer output context potential. It's like one of the weird things about the Pro, or the Plus and then Pro tier, is that you go from like 16 to 32 to 128K context output length, or input length as well. So there's like really, it's kind of evolving in the background, but I do think that at least in the industry, people think it is a very high priority.
So my question is also around, like, even if it's a 120K token context, it's not going to actually follow those instructions exactly, right?
Yeah, that's like a fundamental problem,
Yeah.
where you can't ask, you have to ask it 10 things one at a time rather than one prompt with 10 things. And I am guessing that it'll be abstracted into, like, sometimes your general query will be handled like deep research, where the model is like, okay, I need to break this down into multiple queries and then get back to you. But for now, it's just not worth it for them to add that complexity.
Good. Because at least from a personal experience, I found often rearranging the prompt sometimes works. So
yeah, or you just like save part of your prompt for a follow-up rather than including it in the prompt, which is like so annoying. It's like, I don't want to do this at all.
Thank you.
Okay, thanks for the good questions, and for Nate for his knowledge and his stamina over the last 60 minutes. We're going to do a 10-minute